In this video, I'm going to talk about factoring and look at some basic examples of factoring. It is a common thing used in pretty much any math class after Algebra 2. It's used in calculus, used in pre-calculus, pretty much anything will involve factoring at some level. It may be a little bit more complex or simplistic. It just depends on the course. So factoring, let's define it first of all, is rewriting an expression as a product of its factors. Now this word factors is getting thrown around a lot. And what does it mean? Well, here, let's look at a basic example. So 12. If you've been in school, you probably have done this before. You made a factor tree. So I know that 12 is 4 times 3. And I know that 4 is 2 times 2. So what I've done is I've found the prime factorization of 12. And I can rewrite it as 2 times 2 times 3 equals 12. 2 is a factor of 12, and 3 is a factor of 12, because I can write it as a product. 3 times 2 times 2 equals 12. The same thing is true of polynomials. This in particular is a trinomial, and I'm writing it in terms of two binomials multiplying each other. So I have x squared plus 2x plus 1, and that equals x plus 1 times x plus 1. Well, you could be wondering, how do you know that x plus 1 times x plus 1 equals that? Well, I can just use the FOIL method. So FOIL, if you remember, x times x, which is x squared. That's the first term. Outside, I do x times 1, so that's plus x. Then I do x plus 1, which is x, and finish off, I do 1 times 1. And essentially what we're doing is the distributive property, just in a little bigger terms. So here I have x squared plus 2x plus 1. And so I know this is the factorization of this. Now another important idea we need to talk about is something called the greatest common factor. Now greatest common factor is used quite a bit actually. If you get into any mathematics courses, at least when you're talking about number theory, this idea is used a lot. But in this class, or whatever class you're using factoring for, you're going to have to understand this idea. And basically what it is the greatest common factor of the terms in the expression. And I'll show you what I mean by that in just a minute. So first of all, I want to look at this case of factoring the greatest common factor. And it originates from the distributive property. So if you remember the distributive property, it's when I distribute. So I do 2 times 3x gives me 6x. 2 times negative 2 is negative 4. Same thing here. If I distribute, I'm multiplying these. So that gives me negative 4 times 4 is negative 16. Negative 4 times negative x is plus 4x. This is something that you probably learned in Algebra 1 if you took it somewhere. What we are trying to do is to go from essentially this form of an expression into this form of the expression, trying to figure out what is that number here. And this number, or number and variable, is going to be your greatest common factor. So looking at this one, I'm looking at 2x squared minus 98. Well, I know that 2 is even, and so is 98. So I can go ahead and factor out a 2. That means I write it like this: 2 times x squared minus 49. So basically, I'm dividing each of these by 2 and putting it on the outside. And if I wanted to check my work, I could go ahead and distribute, do the opposite, and I'd get 2x squared minus 98. So I know that I factored it correctly. I can't take anything else out because this is a 1 and that's a 49. And this has x squared and this doesn't have any x's. So I can't do anything else with it. Looking at this one, well, I know 3 divides 3 and 3 divides 24. This has an x, this doesn't. So x's stay the same. So I'm going to have 3 times x squared minus 8. And actually, for those of you people who want to correct me, you can keep factoring this one. We're not going to mess with that in this video. I'll get to it, promise. Now let's factor a trinomial. And what I'm going to show you is something called split the middle. And essentially what we're going to do is we're going to split this middle term into two parts. But before I get ahead of myself, let's talk about the procedure. The first thing you're going to do is you're going to multiply this a times c. Now you could be wondering, well, there's no a, that's a 1. True. But this is standard form, ax squared plus bx plus c. So what I'm going to do is I'm going to look for a and multiply that by c. Well, 1 times negative 36 is negative 36. And this is going to be important. You could be wondering, why is this little table over here? Here's why. I'm going to make a table. And what I'm going to look for are what are some factors that multiply to be negative 36, yet add to be negative 9. See, b is important here. So let's see. Let's think. How about, let's pick one that we know won't work. What about 6 and negative 6? Why not? 6 and negative 6. So 6 times negative 6, that's 36. But 6 plus negative 6 is 0. Well, that doesn't equal negative 9, so it's not going to work. You can put an X there or something to make sure you know you don't use it. Let's try the one that does work. Let's do negative 12 and 3. So let's see, negative 12 times 3 is negative 36. Add those together and I get negative 9. So yes, this is the one I'm going to use. So here's what we do. We're going to take our original polynomial, 9x minus 36, and I'm going to split the middle. Let me show you what I mean. So I'm going to write it like this, x squared minus 12x plus 3x minus 36. Now you could be wondering, where in the world is this coming from? Well, this is coming from right there, negative 12 and 3. So I split it into those two components, and negative 12x plus 3x still equals 9x. So this is equivalent to this. Now what I'm going to do is I'm going to group this into two binomials. And with those binomials, I'm going to factor out, well, the greatest common factor of each. Here I have an x squared. Here I have a negative 12x. Well, my coefficients, I can't take anything out of that, but I can take out an x. So I'm going to take out x, and I'm left with, let's see, x minus 12 plus. Here I'm going to factor out, well, a 3, because I have a 3 here. 3 divides negative 36, so I get 3 times x minus 12. Now something interesting comes up from this. If you take a look, let me go ahead and highlight that. X minus 12 is in both parts. And so what I'm going to do is I am going to actually factor out x minus 12 from x times x minus 12 and 3 times x minus 12 to get this. X minus 12 times, well, what do I have left? I have x and I have plus 3. And if you don't see where that comes from, it comes from right here. So I'm left with x, that's there, and I'm left with a plus 3. So now I've factored this, and let's check and see if I did it correctly. So I have x minus 12 times x plus 3, and I'm going to FOIL, let's see, x times x is x squared. First, outside, that'll be plus 3x. Then I'm going to do inside, so that's minus 12x. And let's finish off with last, that's going to be negative 36. Then we combine our like terms, so I have x squared minus 9x minus 36. And we need to say something, because we worked hard on that one. There we go, some smiley faces to brighten your day. And so there we go, x minus 12 times x plus 3 is the same thing as x squared minus 9x minus 36. It's just factored. Let's do one more example of factoring a basic polynomial. So if you remember, the first thing I'm going to do is I'm going to start out by multiplying my a and my c. So let's see, I'm going to do 1 times 21, and that's going to give me, well, 21. So let's see, now what I'm going to do is I'm going to look for what are two numbers that multiply to be 21, yet add to be negative 10. Let me give you a hint on this one. They're both going to be negative, because I know a negative times a negative gives me a positive number, and a negative plus a negative, well, is negative. So in this case, we're going to use negative 3 and negative 7. So let's see, I add those together and I get negative 10, and multiply them, you get 21. So these are the two numbers that we're going to be using. So let's see, I'm going to take my polynomial, so x squared minus 10x plus 21, and I'm going to split the middle again. So x squared, I'm going to write it minus 3x minus 7x, and we do plus 21. So I have split it. Now what I'm going to do is, again, we group them. And here's a little thing with grouping. When we have a minus minus, something like this, first of all, you always try and put the negative in the front, so that way it works out nicely. But in this case, since I have two negatives, I'm going to write this as plus negative 7. So my grouping comes out a little bit nicer. We always want to have a plus right here, because that makes distributing nice, because this would be a positive one and it wouldn't affect what I'm factoring. So now what I'm going to do is I'm going to factor out the greatest common factor. So here, let's see, I've got x squared, I've got minus 3x, so I'm going to take an x out of it. So let's see, that's x times, well, I'm left with x minus 3, and if you want to check, you can do x times x squared, x times minus 3 gives you minus 3x. Plus, in this case, I'm going to factor out a negative. I'm going to factor out negative 7, because if you remember in the last example, this had to match what was over here. So when I factor out a negative 7, this leaves me a positive x, and well, that makes this a negative 3. So like we saw in the last video, or last example, this and this match. So now all I have to do is I have to finish it up. So I'm going to have x minus 3 times, well, x minus 7. And that's it. Again, you can go back and factor it, or FOIL it, and check that you did it right, but we're good to go. So that's how you do basic factoring.